Hello everyone, welcome to my YouTube channel. I am Harshita from Sri Venkateswara College of Engineering. In this video, let us discuss about two-way Anova. First of all, let us know the definition of two-way Anova. Two-way Anova is a statistical test used to analyze the differences between groups when there are two independent variables. It allows for the examination of the interaction between these variables and their individual effects on the dependent variable. Now let us see the purpose of two-way ANOVA. The purpose of two-way ANOVA is to determine whether there are significant differences between groups based on the two independent variable. It helps to identify the main effects of each independent variable and whether there is an interaction effect between them. Now let us see the formula of two-way ANOVA. The general model for two-way ANOVA can be expressed mathematically as follows. Yijk is equal to mu plus alpha I plus beta j plus alpha into beta ij plus eijk, where yijk is observed value for the kth observation in the jth cell. Mu is the overall mean. Alpha I represents the effect of the ith level of the first factor. Beta j represents the effect of the jth level of the second factor. Alpha into beta ij represents the interaction effect between the ith level of the first factor and the jth level of the second factor. Eijk is the random error. Next, let us see the hypothesis testing in two-way ANOVA. First, the formulating hypothesis. In two-way ANOVA, we test hypothesis about the effects of two categorical independent variables on a continuous dependent variable. The null hypothesis H0 states that there is no significant difference between the means of groups defined by independent variable. The alternative hypothesis HA states that there is a significant difference between at least one pair of the mean. And the next, let us see the testing hypothesis. To test the hypothesis, we calculate the F statistics by comparing the variation between groups to the variation between groups. If the F statistics is greater than the critical value, we reject the null hypothesis and conclude that there is a significant difference between the means. If the F statistics is not greater than the critical value, we fail to reject the null hypothesis and conclude that there is not enough evidence to support a significant difference between the mean. And next, let us see some of the assumptions of two-way ANOVA. First is independence. The observation within each group and across different groups are assumed to be independent of each other. And next is the normality. The residue, the difference between observed and the predicted value of the dependent variable should follow a normal distribution. And the next is homogeneity of variance. The variance of the dependent variable should be equal across all levels of independent variables. And the next is the interaction effect. There should be a significant interaction effect between the two independent variables being. And let us see some of the advantages of two-way ANOVA. Two-way ANOVA follows the analysis of the interaction between two independent variables on dependent variable. It can provide insights into the effect of multiple factors and their interaction on the outcome variable. Two-way ANOVA is useful for identifying significant differences between groups and understanding the relation between variables. It can be used to compare means across different conditions or groups. And let us see some of the limitations of two-way ANOVA. Two-way ANOVA assumes that the data follows a normal distribution and that the variance are equal across groups. It requires a large sample size to ensure accurate results. Two-way ANOVA may be approximate if the data violates the assumption of the test. Interpreting the result of two-way ANOVA can be complex, especially when there are significant interaction between. Let us see the example of two-way ANOVA. Suppose we are studying the effect of two factors A and B on the performance of students in an exam. Factor A represents different teaching methods, method 1 and method 2, and the factor B represents the different study duration, short and long. The dependent variable here is the exam score. Here are the hypothetical data. Method 1 short 75, 78, 60, 82. Method 1 long 85, 88, 90, 92. Method 2 short 70, 72, 74, 76. Method 2 long 80, 82, 84, 86. Let's say the p-value for factor A is 0.03, for the factor B is 0.01, the interaction effect is 0.05. Finally, I conclude that the conclusion of the two-way ANOVA involves the determining whether there are significant mean effect for each factor, a significant interaction effect between factors, or both. The analysis helps to understand how variation in the response variables are influenced by the independent variables. If significant effects are found, post-act test may identify specific differences. Practical significance should also be considered. Overall, a two-way ANOVA provides insights into the relation between the factors of the response variable in the study. And thank you for watching this video.